Let's dive right into today's explainer and tackle a brilliant way to level up your code architecture. If you've ever found yourself pulling your hair out over messy, repetitive code bases, well, you're absolutely in the right place. Today, we're unpacking the template method design pattern. It's a structural approach that is literally all about standardizing your workflows while completely wiping out redundant code duplication. By defining an algorithm just once and only customizing selected steps, you're going to save yourself hours of future debugging.
Here is a quick roadmap for us today. We'll start with the developer's dilemma, break down what the template method actually is, look at the anatomy of the skeleton, write it out in Java, and wrap up with some real-world applications.
Section 1. Same process, different steps. The developer's dilemma.
Let's kick this off with a scenario I think we can all relate to. Be honest with me here. Have you ever copy-pasted an entire block of code just to tweak one tiny step right in the middle? Maybe you had to load data, process it, and then save it. The loading and saving are absolutely identical, but the processing is just slightly different. We've all been there, right? It feels like a quick fix at the time, but man, it creates an absolute nightmare for maintaining consistent code bases as your app grows. Because the second a bug pops up in that common code, you suddenly have to hunt it down and fix it in 10 different places.
And that perfectly illustrates what we're focusing on today. Think about a situation, we'll call it scenario F, where you have several classes following the exact same process, but some individual steps within that process are implemented differently. Now, to be clear, this isn't about creating objects, and it's not about wrapping incompatible interfaces. It is strictly about a shared workflow that has localized variations. Whenever you run into this kind of scenario in the wild, the template method is exactly what you need.
So, where does this solution actually fit into the grand scheme of software design? Well, design patterns are generally split up into creational, structural, and behavioral categories. The template method falls squarely into the behavioral bucket. That just means it's fundamentally concerned with defining communication and assigning responsibilities between objects. It dictates exactly how different parts of your code should interact to get a job done securely.
Section 2. What is the template method? Defining the algorithm.
So, how do we actually solve this headache of repeating similar but not totally identical processes? The secret is really in the definition itself. The template method defines the skeleton of an algorithm in a superclass, but it allows subclasses to override specific steps without changing the algorithm's overall structure. Think of the superclass as a super strict manager. It tightly controls the sequence, the overall workflow, and those common operations. The subclasses, on the other hand, well, they're your specialists. They only control the variable steps, stepping in to provide specific domain-level implementations.
It's kind of like a literal skeleton. The algorithm itself, the bones, is permanently fixed in the superclass. This guarantees nobody can accidentally mess up the sequence of operations. Step 1 goes to Step 2 to Step 3. That order is totally locked down. The subclasses are just there to provide the custom flesh for certain variable steps. The big takeaway here is that a subclass can absolutely change how a step is performed, but it literally cannot change the overall sequence. Control stays 100% with the superclass.
Section 3. Anatomy of the skeleton. Visualizing the workflow.
Let's break down how this actually builds a structured sequence, step by step. When you map out the operations, the flow just naturally alternates based on what you need. You might start off with Step 1, which is a fixed, common step that applies everywhere, say opening a database connection. Then Steps 2 and 3 might be your variable steps, where the subclass injects its very specific behavior, like how to format a particular file type. Finally, Step 4 jumps back to a fixed step, like closing that connection. The superclass handles all the fixed stuff and simply calls out to the subclass for the variable ones at the exact right moment.
And this right here perfectly highlights why this should matter to you as a developer. Without the template method, you're stuck repeating algorithms across all your different processors. If you've got a CSV processor and a database processor, they're both going to load, clean, analyze, and generate reports. Doing all of that without a template practically invites inconsistency and makes your code a massive pain to maintain. But throw the template method into the mix and you get centralized common operations. You drastically cut down on duplication, boost your code reuse, and honestly, you make future maintenance an absolute breeze since that core logic lives in exactly one place.
Section 4. Writing it in Java. Moving from blueprint to code.
All right, enough of the abstract theory. Let's actually look at how this plays out in your IDE. Say we have an abstract class called data processor. Now, pay really close attention to the clever little use of the final keyword on the process data method. It says public final void process data. That right there is our ultimate control mechanism. By declaring this template method as final, we are completely preventing any subclass from coming in, overriding it, and rearranging our fixed sequence. Inside that method, it calls load data, clean data, analyze data, and generate report in a very specific, strict order. The load data and generate report methods are fully fleshed out right there in the abstract class, but clean data and analyze data are marked as protected abstract methods. Basically, those are our hooks.
And this is where the magic really happens. Crucially, our concrete implementations, like, say, the CSV data processor and database data processor classes, they only use the override annotation for those specific steps that vary. So the CSV processor tells the program how to clean and analyze CSV data, while the database processor just gives instructions for database records. And because we declared the process data template method as final back in the parent class, our core algorithm stays entirely untouched. When your client code runs process data on the CSV object, it flawlessly executes the parent's fixed steps, tightly interwoven with the subclass's custom logic.
Section 5. Real-world applications, exams, and e-commerce. To really lock this concept in, let's zoom out a bit and apply this pattern to some complex systems we interact with all the time. Take a university exam process. It fits this pattern beautifully. Whether a student is sitting down for a theory exam, a programming exam, or a practical lab exam, the overarching sequence is exactly the same. The university always registers the students first, and it always publishes the results last. Those are your fixed, common steps. But the stuff in the middle, preparing the exam, conducting it, and evaluating it, that varies wildly. A theory exam needs a written test and manual grading, whereas a programming exam is probably going to use an IDE and some automated evaluation. So the template handles all the bureaucracy, while the subclasses handle the specific exam format.
We see that exact same brilliant structure over in e-commerce systems too. Just think about processing online shopping orders. Standard, premium, and international orders all need to have their cart validated, their price calculated, and their payment processed in exactly the same way, to ensure financial security. But the prepare shipment step, that varies heavily depending on the tier. Premium gets priority packaging, while international suddenly requires a bunch of customs documentation. The template method lets developers lock in that secure financial workflow once in the superclass, which then allows each specific order type to customize only its unique shipping prep.
So as we wrap up today's explainer, I want to leave you with a quick, actionable thought. Just think about your day-to-day work for a second. What is one process in your current code base that could totally be refactored into a template method today? Take a hard look at your own code, hunt down those hidden, copy-pasted algorithm blocks, and start building out your skeletons. By using this straightforward behavioral pattern, I guarantee you're going to write cleaner, much more resilient, and way more maintainable software. Thanks so much for joining me, and happy coding.